extend my warm welcome to everyone present here, joined for today's webinar conducted by IEI Civil Engineering Chapter of MEA Engineering College in association with Civil Engineering Technical Association. The session will be handled by our Honorable Resource Person of the Day, Dr. P.R. Sri Mahadevan Pillai, on the topic Optimization of Structural Steel Design. Before heading on, I would like to remind the audience to keep their microphones muted throughout the session. If any enquiries may be dropped in the chat box. Now, I would like to call upon Mr. Asmail Bani K, Assistant Professor of Civil Engineering Department at MEA Engineering College, for the welcome address. Sir, please.
Good afternoon all, Honorable Chief Guest, HOD, teachers, and my dear students and friends. A warm welcome all. It's a great pleasure and great moment for us to have our Chief Guest, Dr. P.R. Sri Mahadevan Pillai sir, Principal and Director, Ahilya School of Engineering and Technology, with us today for our webinar. First of all, on behalf of IEI Chapter MEAEC, I would welcome you all to this prestigious program about optimization of structural steel design in association with CETA and Anova Consultants. Thank you. Once again, thank you all.
Thank you, sir. Now, moving on today's session, I would like to introduce Dr. P.R. Sri Mahadevan Pillai, currently working as the Director of Ahilya Group of Institutions and also the Principal of Ahilya Group of Engineering and Technologies. With much respect and pleasure, I kindly invite Dr. P.R. Sri Mahadevan Pillai, sir, to present the webinar on the topic Optimization of Structural Steel Design. Sir, you may please.
Good afternoon to all of you. Am I audible? Can you hear me properly?
Yes, sir.
Yes, sir,
Sure.
you are audible.
Okay. So let me start with the presentation. So can you see the presentation?
Yes, sir.
Can you see my screen?
Sir, sir.
Yes, sir, it is visible.
You can. Okay. So this is today's topic, optimization of structural steel design. As you know, iron is the second most abundant element available on the earth. In some planets, like Mars, it is the most abundant material available. On Earth, aluminum stands first and iron second. So iron has been extracted as a material useful for humanity long back. And it has been used in construction over many centuries, we can say even millennia. Even today, it is one of the construction material which has no easy replacement. Though concrete has become the most abundant construction material using the binding material cement, Iron couldn't be replaced even there. To make the concrete strong, we need iron, or we rather say it is steel. Iron with a slight impurity is called steel. We will see what is that impurity meaning. So steel is called the construction material, whereas iron is the element. I told very less percentage, maximum 1% impurities only will be there. Beyond that, for construction, it is unsuitable. And we have got many types of sections which are used for construction. Present day, we have got what is called hot rolled sections and cold rolled sections. Hot rolled sections are commonly used for shapes which are shown on the upper half of this diagram. You see the screen. For example, the structural steel sections which you get commonly in the market, I section or channel section or L section or T section or plate section or square or circular bar sections. These are all mostly hot rolled sections. Hot rolled section means the steel scrap or iron ore will be heated to 1550 degrees centigrade. It will be melted, and the melted liquid, that is steel in liquid form, will be poured into a mold, and this shape of cross sections will be made. Whereas on the bottom side of the diagram you can see, which are called cold formed sections. They are made by applying heavy pressure on cold steel. And because of that, making hot rolled steel is comparatively easier compared to making cold formed sections, because cold formed section needs heavy pressure of many tons to make something to a sheet, whereas in hot rolled sections it is in liquid form. The molten liquid can take any shape, and the mold will provide the shape. But here itself starts what is called optimization. Optimization in steel means the less steel you use, the more optimum you are doing. Steel is a very costly material. Steel in the market, based on the shape, size, quality, varies from 50 rupees a kilogram to 100 rupees a kilogram. For example, the bar, which we call the rebar, reinforcement bar, the cost may vary from 65 to 75 rupees per kilogram. Or normally, the cost is expressed in tons. 1 ton, 1000 kilogram, may be around 50,000 rupees to 1 lakh rupees steel right now, based on what is the shape and what is the type of steel we use. So saving steel is called optimization. Optimization is possible in many ways by using advanced optimization techniques. There are many optimization techniques which I think at the undergraduate level you may not study it. Optimization techniques in design you'll be studying only in postgraduate level. We have got different methods for it. The genetic algorithm method, the artificial neural network method, the FEM analysis method, the FDM method, the AND theory method. So many methods are there. Any one method may be used for mathematical optimization of sections and shapes. Other than that, simple theories like theory of plate, theory of shell can be used for optimizing a structure. At the BTech level, you'll be learning a bit of the theory of plates and theory of shells. There is an elective in structural engineering where theory of plates and theory of shells are being taught. But at the postgraduate level, it is a regular paper. Theory of plate will be one paper, and theory of shell will be another paper for a PG in structural engineering. There will be studying what are the advantages of shapes in making the element strong. A very simple example. I think this is a sheet of paper. If I hold like this, it bends like this. But if I fold like this and keep it in a folded plate shape, this is called the folded plate shape. If I keep this in the folded plate shape, It's much more rigid. It's a rigidity modulus of the shape, not of the material, increases a lot. So the other paper which was lying like this has bent like anything. But if it is in this shape, it doesn't bend. This is the basic theory of plate, or this is what is called the theory of folded plate. Similarly, instead of simply keeping the paper, if I bend it like an arch, like this, arch can be, a circular arch, parabolic arch, hyperbolic arch, even triangular arch, whichever is the arch form, the arch will have a heavy load carrying capacity. That is the theory of shells. So theory of shells and theory of plates are highly used in optimizing the use of steel sections. Very thin sections can be used for carrying heavy load by using these things, these theories. In addition to that, the thickness of the structure can be optimized by its shape also. See, these are called light gauge sections. All these light gauge sections are either using the theory of plates or the theory of shells for improving its rigidity. They will not bend easily. They are all very thin plates. Light gauge structures, light gauge steel plates may be even right from 1 millimeter onwards to 2 to 3 millimeters. More than that, it is normal gauge. So this is very light gauge steel. Even half a millimeter light gauge sections are there. But the shape which you are seeing gives it rigidity. So this is one method of optimization by shape. By shape, we can optimize the optimize means in steel, optimization means two things. One is the weight of the material. Weight of the material is the main optimization. Second thing is the overall space requirement for transporting, for carrying, etc., comes to the cost optimization. And optimization steel is basically not only in steel, any construction material, the term optimization means reducing the costs. Whereas some of you would have studied what is called project management. In a project, there are two things to optimize. One is time and one is cost. Whereas in steel, time is irrelevant because you're buying it. Only the cost comes in optimization. So this is the basic concept of optimization. So keep in mind, there are steel cross sections, hot rolled, cold rolled. In Palakkad district, there are around 42 steel mills. All of them are doing only hot rolling. Why? Because if you have an induction furnace and a pouring facility, you can have hot rolling. Whereas cold rolling needs a lot of machinery, heavy machinery, unaffordable machinery for small units. Only heavy units like Bilai or Vaishak, they are having the cold rolling facility. That is why Palakkad, nobody makes the cold roll sections. They all make, not only Palakkad, even in Kozhikode district, some steel rolling mills are there. They're all doing only hot rolling. Though cold rolling is more stronger in some cases, not always. Okay. So as I told, the steel has got abundant application. This is an industrial building. In this industrial building, 1 to 20 are marked. See the wide variety of application. Even if you are making a building with the concrete, you cannot have any location in the building without steel. The concrete will be reinforced with the steel. The wooden door will be having steel handles, steel hinges. The window will be having steel bars and steel plates. Anywhere without a clamp or without a hook or without a bar or without a plate, it is difficult. So these are all steel things. So in this industrial building, they have numbered 20 locations where 20 different steel elements are there. Starting from portal frame rafter, portal frame column. Portal frame you will be studying in 6th and 7th semesters, the analysis of portal frame, the plastic hinge formation, the plastic and limit state analysis of portal frame, that you will be studying. I'm just showing that these many parts are there even in a single industrial building. And remember, designing a steel structure needs a lot of experience and information. The cases you come across will be myriad types. For example, last week I had to visit a steel mill, steel rolling mill at Palakkad. It's a big rolling mill. so many tons capacity. I think their daily capacity is some 20 tons or 30 tons like that. Steel is being produced. So the why I went there is their requirement is a slight thing. They are right now using only 2 EOT cranes. Overhead electric cranes are there. EOT means electric overhead transmission cranes. 2 EOT cranes are there, 10 tons each. 10 ton 1 ton and 10 ton another crane. They want an additional 25 ton crane in addition to the 20 tons they are having. And the structure is already built. The gantry girder is already there. The crab girder is there. The columns are there. How to do it? Anyway, we can find solution. I'm not going to discuss the solution. I have already found the solution, and we are going to upgrade that crane from, it is overhead crane, moving crane in industry, not the ground crane. So the EOT will be upgraded from 20 cranes to 45 cranes. It is possible only because it's a steel structure. Even there, the only difficulty which we have come across is the existing columns are spaced at 6 meters apart, and they are having RCC footing, and nothing can be done on that RCC. It cannot be further loaded. It will sink like anything. It will sink like a pin if you load it more. The soil cannot take it. So the only difficulty is with RCC. That is why we have to have another columns. We have to have another set of columns with another RCC footing. Because footing cannot be steel, it will go on rusting. These are some of the practical difficulties and practical advantages of steel structures. The steel which we are using are normally these 5 categories. In construction, we use the 2nd, 3rd, and 4th categories. In construction, we use mild steel. We don't use dead mild steel in construction because dead mild steel is, of course, more of iron, not of steel. Strength is very poor. But mild steel, which we use in reinforcing bar, is around 0.2% carbon. Any steel which has got carbon content 0.15% to 0.3%, we call mild steel. The mild steel rolled bars, round bars, which we use in construction. Earlier, we used only mild steel. Then only came the medium carbon steel and high carbon steel. The high carbon steel we call the HYSD bars in construction. When you go for structural design, you have what is called the HYSD bars, high yield strength deformed bars. They are nothing but high carbon steel. But even the high carbon steel in construction, we don't go beyond 1% carbon. Even 1% is very high. 1.5% carbon will be in some special cases only, because 1.5% carbon means the steel will be very brittle. And if the steel content is more than 1.5%, we call it as the carbon tool steel. They are used only for making tools, cutting tools like that. Hammering tools should not have high carbon content. Only cutting tools. Cutting tools, I think you would have seen in your mechanical workshop. There are so many tools used for cutting steel and other materials. They are called cutting tools. They are called high timber steel. They are also called carbon tool steel. This is picked with a stress strain curve. For a mild steel, you can see at the top. And in the bottom diagram, the topmost diagram is alloy steel. And below that, it is low alloy steel, high strength low alloy steel. And at the bottommost, you can see carbon steel. Carbon steel, which is used for tools and machinery. Remember, based on the category of the steel, the stress strain behavior is different. This we always use in construction. From the construction point of view, the mild steel is advisable in earthquake prone area. Reason, mild steel will show symptoms of failure well in advance, whereas high carbon steel or HYSD bars will be more brittle and will fail more easily. That is why in mild steel area, for example, I had some work with the Lettur area. The Kerala state Nirmala Kendra has constructed a good number of buildings in Lettur after the earthquake there. We used mild steel only there. We didn't go for high strength steel because that is an earthquake prone area where high strength steel will break without any indication on a heavy earthquake. Anyway, these are general knowledge which you have to have with regard to steel. And obviously, you would have studied the steel stress strain curve this bold line, bold line is a stress strain curve. But in reality, if you take the internal stress of the material, the curve will be going like this dashed line. That is actually actual, the actual stress diagram is that. But this is the nominal stress diagram which we draw in our record book, because to draw the actual stress diagram, every moment we should get the actual cross section. Actual cross section will go on reducing after the steel reaches this point, which is called the upper yield point. I think you would have studied upper yield point. So why I'm telling this is all these parameters are very important in optimizing the design of steel. Also, in a section like I section or channel section, we feel that the stress variation along the flange and web may be the same. You know what is flange and you know what is web. If it is an I section, the top and bottom planes are the flanges and the vertical member is the web. But the stress variation in the flange and web will be different. The left diagram gives you the stress variation on the flanges, and the right diagram gives you the stress variation on the web. And this is actually the finite element modeling of how the stress this test you would have done in your lab. This test is called the tension test. Tension test you do in the lab with the help of a UTM. When the tension test is done, with the help of tensors and strain gauges, we can plot this diagram. This is the FEM simulation of the stress formulation here. FEM, it is so many softwares are now available for FEM. FEM, finite element method. I think I heard that many are third year students. They may not have studied FEM. But fourth year, definitely we are going to study FEM if you have not studied it. So this is an FEM modeling of a tension member which is subjected to the standard tension test. So the failure pattern, this is the actual failure pattern of the member, and this is how the pattern changes if you take the stress diagram of the member by finite element modeling. Of course, the steel frame has got much more advantage compared to that. Is why we can optimize a lot in steel. Right now, I have come across a very peculiar situation. I'll tell you what is the situation. I have to go for steel structure, no other choice. I have two houses at Trivandrum city close to each other. One house is bigger, one house is smaller. The bigger house got a car porch, but the column is so close that the car cannot easily turn. Very dangerous to turn the car inside. So I have to shift the column. But above the column there is a room. So if I shift the column, the room above the column will be spoiled, may crack. So I have to shift the column without the room above is affected. You cannot do anything with concrete, because even if you construct a concrete beam below it and construct a concrete column below it, the moment you transfer the load, the concrete will settle. That is a danger. So the only way possible is this existing beams can be extended with the help of steel frames. See, these are some of the advantages when steel structures are coming in. So not only that, in most of the places, the sections of concrete can be highly reduced by properly positioning steel elements. Even many of the tall buildings, we have got what is called core reinforced columns, whereas a concrete will be reinforced at the core with the heavy steel sections, not like bars, square bar or circular bars. They'll be having steel sections inside in tall buildings. Many of the tall buildings in the world, and this construction technique is highly utilized in countries like Japan, because concrete cannot withstand the earthquake effectively, and the steel core will be effectively resisting it. So I have listed some of the advantages of using structural steel frame, and these advantages also make it helpful for reducing the cost of the structure. And cheap versions of steel elements are available in the market, Very simple case. I'll tell you one example. Some years back, a person wanted to construct a cold storage at Palakkad. Cold storage was not here. Then this person wanted to invest in a cold storage, and I never saw a big cold storage till then, and I had to design the cold storage. So I decided to visit cold storage. In Andhra Pradesh, there are so many cold storage, big cold storage of 10 to 15 meter height, that is 3 to 4 story building height, big cold storage. So I went there and I was inspecting the material around. We think that steel material will be highly conducting, heat conductor, but I have seen that the construction technique used is 2 steel sheets with in between polyurethane foam pressed between them. That is used for the wall of the cold storage. Very lightweight, very cost economic, and the conductance is almost nil. That why I'm saying this is so many such materials are there. These are some of the panels which are used for roofs in the Western countries for optimizing. If you go for concrete, the cost will be much higher, but these roof panel sections where 2 sheets of steel, thin sheets, will be filled with another material inside. So it is normally known by the name double skin roof. Double skin roof means 2, like cold storage I told, 2 skin is there made of steel. In between the polyurethane foam will be different thickness. You can have the polyurethane foam, 5 centimeter, 10 centimeter, even 20 centimeters available. And readily it is available in the market. You may not have seen it. Such panels are available for reducing the cost in roof construction and commonly available all over the world. Similar materials are used for wall panels. In India, it has not come up commonly, but it will, because instead of going for heavy walls, of course, you can have a steel wall, but the problem is the heat effect will be much more. You cannot stay inside, but you can go for this material. This will optimize the cost, and that optimization comes because you are having 2 thin steel sheets between which a resinous material, either polyurethane or polystyrene, will be filled, and thickness can be adjusted. Thickness can be 5 centimeters or 10 centimeter wall, and this is a common material. Even in the metropolitan cities in India, this is used for optimizing the cost. And for mezzanine floor construction, in between floors, steel is the most commonly used material since it can be optimally used. And bridge cranes you would have seen, the cranes which move on to or apart gantries, they are always used with steel, not with concrete, because steel only can optimize it. Similarly, for circular vents, for structural steel buildings, all this cost-effective material has come up, and now this I have shown some examples where steel can be, all the huge span construction is done by steel. Let's take, for example, if you want to go for concrete beyond a particular span, you have the technique of what is called grid slab. Grid slab construction is possible. Even that becomes highly uneconomical beyond 20 meters of span. So all the high span, whether it is a stadium or a cinema theater or a hall, this is all constructed with a steel roof with different categories. So all these cases, the optimization will come, and that optimization, now we have to see how that optimization of cost can be done. First thing is, nowadays the cost optimization is normally done by software, manually calculating. There was a time when you used to calculate manually. Manually, how it was done was, we take different possible designs and see which is the cost effective one. Then again optimize it by mathematical principles, and there is a very famous book, Structural Optimization, which I think if at all you get a time, by Dr. Rangarajan, Structural Optimization. Whenever you come across such a book, you can go through it. In that, so many equations are given to optimize it. You choose one section, apply the mathematical principles and see. So this procedure will be followed. The first procedure is, if it is a framed building, let us take, we design the steel frame. Then we use any of the optimization technique theoretical method. One of the common theoretical method is called GA method, genetical algorithm. That is why in that diagram you can have GA method. By the GA method, you just see the optimization possibility, how much the weight can be reduced. So many possibilities will be there. And based on that optimization application, you will resize the structure. And the resized structure, again, you will test for its stresses, because once you design the structure based on the stress and force, any structural design is based on the loads and stresses. That is what is structural design. Structural design means for a given load, calculate the stresses and see whether it is permissible or not. Any design is like that. Only thing is whether it is smaller structure, the check will be less. If it is a bigger structure, so many checks will have to be applied. And then after all these things, you will have to apply common sense and you will have to apply the regulations. Take, for example, there are umpteen number of software available for structural design, even for concrete. Right now, I'm taking a lot of consultancy work. Each structure I give to some of the experts who are my students, who have got a PG in structures. They design it and they bring back to me. They do it on either STAAD or ETAPS or SAAB or something. They do it and bring to me. Every time, the correction which I have to apply is in the design part, not in the analysis part. Analysis part will be pakka, because they all know the analysis. They are doing it with the computers. They all have their laptop having any of these packages. They do it precisely well. But after the analysis is over, when it comes to the design, first thing is common sense. Next thing is caudal provision. Many times the caudal provision will be violated. IS code says, very simple case I'll tell you. A water tank. Last week I had to give a water tank design for Thrissur. It was for government work. My student, who is a postgraduate in structural engineering, analyzed the tank and brought it. And he has given a 12 centimeter wall thickness for the tank. It's a 10,000 liters capacity tank. 12 centimeter wall thickness is theoretically all right. But practically what is the difficulty is, the water tank should have two layers of reinforcement, inner layer and outside layer. Water tank is a water retaining structure, so inside clear cover required is 5 centimeters. And since it is exposed to sun and light and all, the outside reinforcement requirement of a clear cover requirement is 2.5 centimeters. So 5 plus 2.5, 7.5 centimeters is gone. Then two 16 mm bars are there on both sides. So 16 plus 16, 32. That means 7.5 plus 3.2, 11 centimeters is gone between all these things. So the distance between the bars will be only 1 centimeter plus, less than even 1 centimeter. Is it practically possible? So definitely the wall thickness had to be revised. I told him revise the wall thickness by 17 centimeter. Instead of giving 12 centimeter, make it 17 centimeter. Then he was asking me, sir, why we are getting in the design 12 centimeter only. And the software is also correct. Software gives the design 12 centimeter. Software is correct, but software is not sensible. This I always tell the designers. That is why whenever I am entrusting someone to do the design and bring to me, only after checking I can give it to the client. Then the first thing I see is the design dimensions. So why I'm telling this is, after the optimization is done, after resizing the structural elements, you have to again go through the entire process to see whether the section chosen is having safe stress and safe strain. That is very important. The stress and strain, especially in steel structure, the strain also has to be checked. In concrete structures, the stress checking is enough because strain is relevant, because once you check the stress, strain will be within the limit. But steel, it is not the case. You have to check both the stress and the strain, and the cycle will continue. But all these things, theoretically, you don't have to do now. Why? This is the procedure we used to do. In the 80s and 90s, we used to do this way. We had to apply, especially there is a very, very funny method called the ant colony search method, which is an optimization technique. It is based on the theory of ants. Ants, the creatures, small creatures, ants have a peculiar theory in moving in their path. That theory is used in the design of the optimization principles. If you want, you can go to the book of Optimization by S.S. Rao. The textbook Optimization by S.S. Rao, this ant colony theory is well explained, how it can be used for optimizing the size of a steel section. But nowadays, we are not going for any of these theoretical calculations and equations. we have got, of course, this is based on the previous theoretical methods I have told. You will come across when you have reduced the sessions, so many of the structural elements. Say, for example, you're optimizing a truss, a steel truss. Steel truss is normally used for roofing. If you are not optimizing, many of the elements in the steel truss may be having less than its permissible stress, much less. But when you optimize the steel truss, most of the structural elements, whether the tie element or the strut or the diagonal element, most of these elements will have stress very close to the permissible stress. That is called optimization. Avoiding the members having less stress and making the members take more stress is the philosophy of optimization, so that design is economical. For example, you are employing an employee. The employee is supposed to work, say, 8 hours a day. The employee works at least 7 hours a day, it is useful. The employee works only 2 or 3 hours a day, it's a waste of your money. Similarly, every element in a truss or in another frame has to have maximum stress possible, but not beyond the permissible stress. That is the principle of optimization, so that the cost can be reduced. Now, hereafter, you don't have to worry about those theories. You study one software well. At first, I am going to tell you 5 softwares which are widely used in the world in their order of competency. In their order of competency, I am telling 5 software which is exclusively used for steel optimization. You cannot use it for other optimization. But then I'll tell you some other softwares which are, and this software is not basically for optimization. This software, they have one module which is optimization. They are design software. All these are basically steel structural design software, but they have got optimization module. So after in some of the software, the optimization is ipso facto taken in the design also. But after the design also, if you want to check the optimization, some of the software even permit that. Or even if some other manual design is there, you want to check for only optimization, that is possible. The most popular is coming from Autodesk. Autodesk is very famous because you know AutoCAD has come from Autodesk. So Autodesk is having a software called Advanced Steel. It is exclusively for steel design, and it's not very popular in India. It is very popular in the European countries, and you can easily design the steel structures with that, and the design comes optimized by itself. But many of our students are not using any of these things. I'm telling from the international point of view. Then the next one is what is called RAM Steel. RAM Steel is coming from a very famous company, Bentley. Bentley is one more software we'll be discussing, then I'll tell. This is also exclusively, RAM Steel is exclusively for designing steel structures and optimizing it. Then another software is what is called akka. This is the third best for steel design. This is from this akka software company has given the name of the software as Edulus Steel. Edulus Steel. That is their software name. This is also very popular in European countries. This is European software. Then next is Lubal software, which is given by the name RSTAB. RSTAB is their name. Short form for the software which they have given. That is also a steel analysis and design cum optimization software. Then the next one is Tekla software. Tekla is somewhat popular in India, because when I was seeing some of the Indian analysis, I was seeing some people have used Tekla software in India. But the other software which I have told, they are not popularly used in India. So these are 5 dedicated software for steel design. Now there are general softwares. This general purpose design software means any structure you can design. And out of the general purpose software, the most widely used one in India is what is called STAAD Pro. It's a 3D structural analysis and design stuff. That STAAD means structural analysis and design. It's very popular, but I feel that among the students, this is not the popular one. Among the professionals who are doing structural design, STAAD is the best. But again, be careful while using STAAD. STAAD analysis is very popular, but STAAD design, especially with respect to IS code, is sometimes very cumbersome and very awkward. So design, And in general, I'm saying that all the software design has got some built-in limitations. Design is supposed to be based on the country's national code. For example, in India, the steel design has to be based on ISA 800, IS 801, IS 811, and SP6. Many times these conditions are not satisfied in the design. So that is why I told design you have to check again. But analysis, StatPro gives very precisely. And next is SAAB 2000. Earlier, before STRAT came, SAP was the ruling software in the world. SAP was the most, but SAP is only for analysis. If you take analysis alone, SAP is the best software even today. It doesn't give design. Because design, I told, so much mistakes will come. More than 80 codes are there in different countries. Gulf countries are mostly using the British code, BS, and its handbook is Reynolds handbook. Here we have got IS book, codes and IS handbook. Similarly, British codes have got what is called Reynolds handbook. It's much different than the Indian codes which we are using. For example, sometime back, 15 years back, one of my students working in Gulf countries wanted me to do some design for them. So I had to study the BS codes concerned that structure and the Reynolds handbook. I found that it is much different than the Indian codes. Practice, but Gulf countries, they insist on British codes. So if some of you are going to the Gulf countries as a practicing structural designer, you will have to and you must have to study BS codes and the Reynolds handbook. Okay, that is must. Whereas in India, only the IS books which you are studying in the college are sufficient. But I have seen that most of the IS codes that people study when they become a designer, and they are students, some statement or equations they directly take from it and solve the problems. So SAP 2000 is a very good software. And next, ETABS. I don't know what is the reason. Most of my MTech students have been using ETABS for analysis and design. One or two students I asked why you are using ETABS when STRAT is there. They were saying that ETABS is more user-friendly. Maybe that is the reason. STRAT needs a lot of study. ETABS is more interactive. Nowadays, people prefer that. You can, menu-driven. Others also menu-driven. But ETABS is more interactive, means more easy for them to learn themselves. Maybe that is the reason. It is an optimization module also is there. Along with the design, it is optimized. Okay. The other software is Analysis 3D. I have given here version build 2.11. Now new version has come. This is an old version. Now the version, of course, Analysis 3D is the name of the software. It is also having optimization part. Then From Tools Optimization is a general-based package. It's an integrated structural design package where design is secondary, optimization is primary. Optimization is done as per the flowchart given at the bottom. So if you talk from the optimization point of view, compared to all the software in the past which I've shown, this is the software which is more useful for optimization purpose. Then ANSYS is a very common software. ANSYS also, next to ETABS, the software preferred by students is ANSYS. ANSYS has got a speciality. It has got typical varieties for every use. For example, ANSYS for aerospace is different. There is what is called the Aqua ANSYS. Aqua ANSYS means ANSYS for the hydrodynamic design, for wharves, for the oil extracting frames, then floating structures. All these things will come under ANSYS. Has got Aqua ANSYS for that. Aqua ANSYS is exclusively for structures in water. So ANSYS also is a very versatile structure. I think many of the students at PG level are using ANSYS for analysis and design. Any software nowadays, if you spend some time thoroughly with it, you can easily learn. I still remember in the 90s, there came two softwares called MS Project and Primavera. At that time, I was doing my PhD work. I wanted some input from some results from Primavera and MS Project. I sat for 2-3 weeks with this project. At that time, pirated software was available. I couldn't buy it. It was very costly, so many lakhs. I got pirated software, so I worked on it. pirated software for individual use, you can use it, but don't publish it or don't spread it. If the individual is using it, there is no much harm. Study purpose. I used it for study purpose. And I could study within 2-3 weeks those two software. Because nowadays, all the software, we all studied computers also like that. When we were students, there were no computers. Computers came when we were teachers, and we had to study ourselves. So there was nobody to teach us. We had to study ourselves. The first type of computers were, simple character editor. Only one character you can enter and edit. Then came what is called the line editor. Each line you have to enter the program, debug it, correct it. Then came page editor. Now you are having unlimited editing capacity. Any number of pages you can edit parallelly. But those things are very slow. It came only in the late 90s. What I'm saying is, any of this software, don't worry about where I can study. Some people are asking me, sir, where I can study BIM software. BIM software is a comprehensive software. It's not for analyzing steel alone. BIM is, for the entire building information system, BIM. Building information management software, it is comprehensive. It is having a lot of requirement in the Gulf countries, Western countries, all. So now, out of all the software available in market, BIM is the best to study. Even that you can study yourself. Don't worry. The first thing to study a software, you should have your own computer, whether laptop or desktop. Then that software should be with you. Then go on working something on that. Like you are so many hours you are working on the mobile. Some 1 or 2 hours you work on the computer. Have that software with you. Software copy you can get from anywhere. Even BIM you can get from anywhere. Without even a single copy, I told you, without even paying, you can get a software copy for that. Work on it, get some experience, and then maybe at the end, if you are having some doubts, now platforms like Quora or even FB or any Twitter, anywhere you can clarify your doubts, people will help you. And remember, the more learned people are more ready to help. They'll help you freely if you ask them how something is. But without you studying it, you cannot ask it. You study first and come up with some doubt. So don't worry about any of this software. Any software, because this is a procedure in ANSYS program. And now one more thing is, ANSYS has got a student demo version, which you can get free. Maybe that is what attracted students to ANSYS. Student demo version doesn't have the full capacity, but it is given free by the company. It's a licensed version from the company for students. Why they are giving like this is not without purpose. They feel that once you get used to ANSYS for students version, when you become a practicing engineer or a faculty, you will be in a position to buy it, the real version of ANSYS. So it is just like giving a demo version. You go to some bakery and all, they will give you a small piece of sweet. You take it and then you will order for more. That is a philosophy in ANSYS for students. So it's easily available. ANSYS for students, I have not worked much, but I've seen some of my students working on it, and they were shifting out to the real ANSYS immediately because ANSYS for students is so user-friendly. So now we have got some time, some 10 minutes. I don't want it to be monologue. I know the students will have some doubts to clarify. I've been introducing, I haven't gone to the depth of optimization. Optimization is not a joke also, because for optimization in my MTech, I have done 2 courses, compulsory courses where they're on structural optimization. Structural optimization 1 and structural optimization 2. So it's a very, at that time there were no computer facilities like this for optimization. We had to by heart all the equations and then do it manually. But now you don't have any such difficulty. Get a system, do it on the system. That is possible. So I'm stopping my presentation at this point. Now the remaining 5 to 8 minutes time is just for your interaction. And even if you cannot talk something straight away, I prefer the straight shot. Somebody can ask me what they want to know. Even if you cannot ask something like that, I am opening the chat box also. I don't know whether you have understood. Optimization is a high-tech subject, but I have been presenting it in a very, very lighter form so that students can understand, because you are the target audience now. Now, any question you can ask either directly or on the chat box. My chat box also I have kept open. Please come forward. We have got roughly 10 minutes for discussion. If you don't have any questions on optimization, you can clarify any of the doubts in structural design. And I'm sharing an experience with me. The students who have passed out in 2021 are very pitiable condition. They cannot even design a simple slab or simple beam. They haven't done any design in the classwork. So all the employers were telling that they are useless as far as engineers are concerned. So those who have passed out in 2021 and 20 will be really suffering in that profession. 22 people, I think they may catch up. There's a question, sir, in your opinion, which rebar is comparatively good? Tata, Vaishak and all. Okay. It is something which is concerned about practical aspects of rebar. Rebar means the bar which is used for reinforcement in RCC. So it is not a steel design, it is RCC design, let it be. See, there are two ways in which the steel is made. One way is called making from the iron ore, that is primary steel. The second way is making from used steel, that is called secondary steel. So primary steel means you need iron ore, you need the extraction process, you need the purification process. Only two companies in India are doing that. One is Tata Steel and one is Steel Authority of India. Tata Steel is having plants at different places like Jamshedpur, Bhilai, etc. Steel Authority of India, their main plant is at Bhilai. They have got one plant at Vaishak. They don't have any plant in Kerala. So only these two companies are making steel from iron ore. All other companies are making the steel from re-rolled steel, means they are using the old steel and converting to re-rolled steel. The difficulty is when you are using scrap steel for making new steel, there will be rust particles, oxide particles in it that will make the steel rust again. So to be very frank, the original steel which is made from iron ore is far, far better than the steel which is made from scrap steel. But only thing is its price will be a bit higher. If you can afford, buy steel from Tata Steel or SAIL, Steel Authority of India. How can you identify the steel? Nowadays it is compulsory that on the steel bar, the make should be specified. So any steel you buy from Tata, it will be written as Tata on the bar itself at frequent interval. Similarly, Steel Authority of India, if you are buying, if it will be written SAIL, SAIL, SAIL everywhere. Earlier it was not there. Earlier we couldn't identify who made the steel. Now it is mandatory for any steel company to put that emblem on the steel. Like some people were asking me, how can you identify ordinary Portland cement and Pozzolana Portland cement? The contractor asked me, very simple, it is written on the packet. We just clean the packet and read what is written. It will be written there whether it is OPC or PPC, no training required. Another question. Sir, എല്ലാ സ്റ്റീൽ ബാർസ് FE 400, 500 അല്ലേ? പിന്നെ എന്തുകൊണ്ട് ആണ് റേറ്റ്, ക്വാളിറ്റി ഇതിലൊക്കെ മാറ്റം വരുന്നത്? ഏതാണ് നല്ലത്? Okay. Initially, the steel which was used in our construction sector was FE 230 mild steel. Then it became FE 250 mild steel. Then it became FE 315 mild steel. Then became FE 415, 415. Then came FE 415 was HYSD bars, high yield strength bars. Then came FE 450, 450. Then 500. Then 550. Now what is available in the market is mostly TMT, thermomechanically treated steel. Every company is now making TMT. In the process, slight changes made so that the rusting is reduced. That is TMT. Of course, same grading everywhere, it should be the same cost naturally. For example, FE 500 steel of Kairali steel or Prince steel or Paragon steel should be same price. They may be charging separately to exploit the market naturally, because a very simple thing I'm saying, suppose there is mango being sold in the market. Same mango you keep at 3 places. One place, you just say that the mango costs 50 rupees per kg. Next place, you say that the mango sells 70 rupees per kg. And next place, you keep very less mango, but say that it is 100 rupees per kg. A rich man coming to that venue may go for the highest cost because he feels that the cost is attached to the quality. But a man who knows the quality of the mango will see all the 3 places and ultimately buy the cheapest because he knows that all the 3 are the same variety. This is the purchase procedure. This is what is called skimming the market. Skimming, SKIMMING. It's a marketing management technique. Whenever you are offering something, that is why there are people to buy Benz car at 1.5 crore rupees. The same Benz car, you make and sell at 25 lakhs rupees, there may not be people to buy it. Because 25 lakhs, there are competitive materials. They feel that the Benz car at 25 lakhs is not worthy. Whereas Innova car at 25 lakhs may be more worthy. It's a marketing technique. So nothing, but grade wise, the cost will be different. For example, 450 grade and 500 grade, if you compare, 500 grade is a better steel, so the process has to be better. So it will be slightly costlier than 450 grade. That will happen. Sir, why soil structure interaction often ignored during modeling and structural design optimization problems? It is not ignored. I think maybe soil structure interaction is a paper at PG level. And whenever we construct tall buildings, especially buildings more than 5 stories, the soil structure interaction is concerned and soil structure modeling is done. And even the software used nowadays have got modeling techniques. And whether you use a spring model or beam model, whatever model you use, modeling is done. And then only the tall buildings can be designed. But in simple buildings like 2-story or 3-story, soil structure interaction is not done. So I think, Virtiga, what you asked is right. At Malappuram or Palakkad, we may not come to normally buildings with soil structure interaction being taken care of. But we have taken, say for example, there is a hotel building at Palakkad, Sri Chakra. It is fully resting on pile. And I had to be involved with the pile design of that building, and it is taking into consideration soil structure interaction. The piles were designed based on soil structure interaction theories only. Luckily, what happened is in that area, many locations, we could give end-bearing pile at 3 to 4 meters depth. Rock crops were there. Strong rock crops were there. So if strong rock crops are there, soil structure interaction becomes irrelevant because you can have end-bearing piles. Only where, the friction piles are being given, the soil structure interaction is more relevant. Okay, I think I answered your question. It is being considered in optimization also, but in relevant cases. Then any other question here? Somebody has put, thank you, sir. That means time is up. First put it, Ashwin. Okay. Ashwin is very wise. Exactly at 4 o'clock, he put thank you. Though the time is up, if you have got any particular question, 1 or 2 more, I can answer because I'm happy that today I'm comparatively free. Otherwise, addressing will also be difficult. Okay. No other question? Okay, then thank you very much. We will call it a day. I'm thankful to all of you who have patiently listened. And I have recorded this session. So YouTube link will be sent to you so that those students who couldn't listen to this session can listen to that. I have arranged one of my colleague, Professor Abhijit, to record this session. Because with a recording software, this could be recorded. That I'll be sending to you. Thank you very much.
Thank you very much, sir, for such an insightful session. We extend our deep gratitude for taking the time out of your heavy schedule and marking these hours with our glorious presence to present a wonderful session. Thank you, sir. Now, to deliver the vote of thanks, I would like to call upon Dr. Muhammad Sajir. Assistant Professor of Civil Engineering Department at MEA Engineering College. Sir, please.
Good afternoon, all. I believe all of you enjoyed the session, I think. Sir, it was a brief and wonderful session. And we look forward for more from you. On some of the part, I already studied optimization in my EG, but some of the part was very new for me also. I believe all of you enjoyed this session. So now, on behalf of MEA Engineering College, I would like to thank Dr. Sri Mahadevan sir for taking time from his busy schedule to enlighten us. Also, thankful to Dr. Hema Miss for her unconditional support and guidance. Also, thankful to all participants, and once again thankful to all. Thank you.
Thank you. Thank you. Bye.
Bye.
Thank you, sir. Now, once again, I would like to thank everyone for joining us for today's webinar. Have a nice evening. You may leave the meeting after ensuring to fill the feedback form. Thank you.